but I'm going to do two things with spheres. I'm going to use it to cover two of my bases. I'm going to use it to explain finding surface area and volume of spheres, because that's the job, but I'm also going to use it to remind you of algebra, okay? Because you got to be good at algebra. So I'm using this lesson to kill two birds with one stone, which is a horrible saying, but hey, no problem. It's just a saying. Kind of like there's more than one way to skin a cat, which is a gross saying too. But people say it all the time without actually thinking about what it means. So, first thing we're going to talk about is this question. Amber's going to wrap a basketball as a present for her brother. Well, first of all, Amber's a doofus because she would put the basketball in a box and wrap the box, right? Someone hands you a basketball wrapped up like a basketball, it's a pretty safe bet. What am I getting? Ooh, a ball. Question is it surface area or is it volume? Surface area, because the wrapping goes around the outside. It's not volume unless you were to cut the basketball open, stuff it full of wrapping paper, glue it back together and say, here. It wouldn't bounce very well. Thud. Oh, thanks. Right? All right, so it's surface area. So we got two formulas for surface area, right? Now, normally, if this was the very first lesson on something, we'd find the surface area first, wouldn't we? Because we're following the formula. We already know how to work formulas, so like I said, I'm using this to work on our algebra as well, okay? So, I have two formulas. I need to find the radius. Which formula should I use if I'm going to be finding the radius? Should I use the one with radius in it, or should I use the one with diameter in it? Now, I should use the one with radius in it. Could I do it with the diameter one? Of course I could. But we're not going to do that because we want R, so we're going to use the one with R. Now, here is something that you guys, not you guys because you're honor students, but some kids forget. It's this. Surface area equals 4 pi R squared, yes? But in this question, surface area also equals what? $2,500. Because it's right there, right? So that tells us that 2,500 equals 4 pi R squared. Everybody with me? It's a simple piece of logic that every kid always forgets. And you're going to use it a lot next year. All right? Because you have to be able to logically figure out what's going on. And to put it in logic terms, it is simply this. If A equals B and B equals C, then what do you know about A and C? That they're equal, because they both equal B. Picking up what I'm putting down? Use that, because you're going to use it a lot. And it also means you can mix and match. We'll talk about that. There's one question on your review that uses that logic, and you're going to need to use it. Maybe if you figure it out. So we are going to solve this now. What is our job whenever we have a variable that is unknown? Isolate the variable, yes? Okay. To isolate this variable, a lot of people forget what exactly is happening here. What math is this? 4 times pi times r squared, yes? So what do I have to do to get r by itself? I have to divide by what? 4 and pi. Are you with me? So, I divide by 4 pi. They cancel. Now, here's where we get screwed up. What happens over here? It's 2,500 divided by 4 pi, yes? How do you punch that into your machine? Because you can't do that in your head. How do you punch that into your calculator? Tiffany? Then you could do that. That would work, okay? So what Tiffany says, if you didn't hear her, she said she would go 2,500 divided by 4, and then hit the equal sign, I would assume. And that would give her something on her calculator, whatever that would be. And it would be pretty, well, fairly pretty. 2005, 2, 2, 2, Wingardium Leviosa. 2, 2. 2,500 divided by 4. So you've got 625. It's pretty. So 625 pi. Everybody okay with that? Does everybody agree that that's okay? Yeah? All right. So we could have r squared equals 625 pi. Yes? All right. What else could we do with this? Can we get a decimal for it? What would I have to do with this to get the right decimal for it? Bronwyn. Yeah, you would need to put brackets here if you're looking for the number answer. Everybody cool? Because even if you have a smart calculator, if you do 2,500 divided by 4 times pi, it's not going to give you the right answer. Because it's going to do bed mass, isn't it? Okay? Now, the next step is, how do I get rid of r squared? To remind you, again, you already know this, you got to do the inverse operation. What's the inverse of r squared? Square root. So I would square root this. Okay? Now again, can I do that? How would I do that on a calculator? What do you think? So who has an answer for me? I'm not going to write it down until we've talked about it. So what is our radius? Amrit. So Amrit says it's 25 pi. So I'm going to write down a few answers. So Amrit, you say you took the square root of 625, right, which is 25, right? And then you multiplied that by pi, right? That's what you did. Yeah, you took the square root of 625 and pi, right? Now, is that okay algebraically speaking? Yes or no? Do you think? How many people think that that's perfectly fine? Because 625 is a perfect square, right? We're okay with that, 25, 25. What math is this? What math is happening between 625 and pi? Multiplication, right? So really, what is this? Is this a monomial? Is it a binomial? What is it? Who remembers? It's a monomial because it's not subtracted by plus or minus, or separated by plus or minus. That's a monomial. So if I square root this side, then what do I need to do here? Because this is really 625 times pi. What do I really need to do over here? That square root has to go over both of them, doesn't it? Picking up what I'm putting down? So while 625 works, I also got to remember I got to square root the pi. So you can't take the shortcut. You understand what I'm saying? Because this is really a number, isn't it? It's 625 times pi, right? If pi was 3, it would be 1,875, wouldn't it? And I'd have to square root 1,875, which is different than the square root of 625 times 3. Picking up what I'm putting down? Everybody good? So I can't do what she did. I got to square root the whole thing. So here I need an answer. So this is no good. But what I have to do is square root 625 times pi. And all of it has to be under there. Everybody with me? And it ends up being, I can't even remember what. 44? Okay, so 44. So that's the next thing we've tried, right? Is that okay? That's what we say the radius is? So 44 squared times pi times 4 should equal 2,500, right? Check it. Because if this is right, then 2,500 should equal 4 times pi times 44 squared. And does it? No, because this is 24,000 and something, isn't it? So we're still not okay. Where did we make our mistake? Yeah. We can't do this, can we? Because this here, 4 pi, is a number. We just don't write it as a number. Okay? So here is our mistake. And was everybody was cool with this because it made sense, didn't it? 2,500 divided by 4, 625. 625 pi. But that's because you're still not thinking of pi as a number. Okay? This is really closer to 12r squared, isn't it? Everybody got it? Okay, so let's fix this up again. What did I really have to do here? I have to go to my calculator and get what that is. So the real answer, and again, of course, you would think, okay, 44 centimeters. That's half a meter, right? That's a pretty big basketball. So really, I had to do this here. So what is my r squared? It's 2,500 divided by 4 pi. So I go to my calculator. How do I punch that in? 2,500 divided by. Now, what do I have to do to make sure it divides by both? I gotta bracket it. Bracket 4. Now, my calculator's cool. I can just go 4 pi. I don't have to do 4 times pi divided by. Now I get an answer. Now that's a hideous answer, yes? I don't want to write that all out, do I? So on my calculator, on my piece of paper, I'm just going to take the first little bit, 198.94, 198.94. But I'm not going to make that mistake that I used to make where I push clear all the time. Because I've got the answer sitting right there that I need, don't I? So then I'm going to square root. Now, I have an answer key. If you have that spot on your calculator where it says ANS anywhere, that is one of your best friends as you get further and further and further into math. Because you're going to need to be making long lines of calculations. Now, my screen holds a lot of stuff, so I can see lots of stuff on there. I can even move the cursor up and find stuff I did this morning. But most of you don't have that. So you use that answer key. So the answer key is the last thing that I hit equals for. So I'm getting the square root of 198. Then I can hit enter. 14 inches. Or 14 centimeters. Okay? Approximately. It's not going to be perfect, right? Because it's not a perfect square. 14.1 it was. Is everyone okay with that? The last step I did, the finding the square root. So I did, you got the 198? Okay, so that is on your calculator right now. You can see 198. Do 2,500 divided by 4 pi and get the 198 on your calculator. You got it? Now, depending on what kind of calculator you have, you're either going to hit square root answer, or you just need to hit a square root button right now. What happens when you hit the square root button when 198 is showing? That's the answer. Okay? You've got a different calculator than I do. You have a calculator that works backwards from what you see. Now, I can't stress this enough to you guys. All of you have different calculators. You got to know what your machine does compared to what my machine does. Do you understand? I can't, there's, it's too much of a pain to go around and work out everybody's calculator for them. Cool? Okay. Now, let's go to the next one. I just want to do something here so my calculator stays on the screen. There. All right. Now, this next question comes to you and appears to be not a real-life question. It appears to be a math class question, yes? I mean, it's a word problem. It's not going to happen in real life. But, of course, it has real-life applications, right? Why would a guy at a company care about volume and surface area? Why would that even matter? Because it's not just about math class. We aren't showing you this stuff just to say, haha, you're not as smart as I am because I can do surface area. Does it have real life applications? How? What do you think? And don't think of yourself, because that's the next thing. I mean, so, well, I'm not going to get into that industry, so why would I care? That's not what I asked you. Why would it matter if I know and understand surface area and volume in the real world? Where could it fit into place? A question like this. Yeah, it's all about material, right? It's all about cutting costs. It's all about being efficient, right? That's why we do this stuff. So Jim's putting the golf balls into the cardboard box. Do I care about volume or surface area? Volume, because I'm filling the space in the box, right? So I got my cardboard box. Prism, pyramid, what? Prism. So do I know the volume of it? What's the volume of every prism? Base area times height. So it's 3 by 3 by 9, yeah? Which is 81. That's easy. Now, I got to put 3 golf balls in there. What's the volume of a sphere? Fun to say, horrible movie. It's on the page before. Volume of a sphere is 4 pi r cubed divided by 3, yes? Yep, because it's volume, right? Victoria, we need 3 dimensions. How many spheres are going in there? 3. So what am I doing to that whole formula? Multiplying it by 3. What do I get to do to those 3's now? Cancel them out. So in this case, my spheres are 4 pi r cubed. Covers all 3 of them. Picking up what I'm putting down? It saves you steps to write it out. Do you see why? That is a bear of an equation to punch into your calculator. But that is super easy. So by taking 2 seconds to write it out, I can save myself a lot of work, yeah? So now all I got to do is punch that in. 4 pi. What's the radius? Because it's not written in the question anywhere. Or is it? $1.5. And it's cubed. Now please remember, pardon me? Well, the rectangle is 3 centimeters across, and the sphere fits inside it. Right? Okay. Now, the question becomes, you got to know how to do this on your machine. Right? Some of you have an x cubed button. Some of you don't. Some of you have an exponent button. that looks like this. All of you will have an exponent button. It either looks like x to the y, y to the x, x to the blank, y to the blank, or a little mountain, which is called a caret. One of those is on there. You got to know how to use it. Punch that into your calculator. 4 pi 1.5, which you don't need brackets around. Your exponent button, 3, and equals. So all of you should be able to get that answer. Figure out on your machine how that happens. Mine is 4 pi. I don't need to hit times. 4 pi times 1.5. I have to use the exponent button, 3, equals. I get 42.4. Now what do I have to do? With those two highlighted numbers. Subtract it, because I'm looking for the empty space, right? I need the volume of the prism minus the volume of the spheres. And that gives me an answer of 41, 38.6. Everybody cool? Now, listen to me closely. The math is not what's hard, is it? What's hard is using your knowledge to find things like the radius, right? Because Danielle, right away, it's 1.5. And then as soon as I said to you what it was, Jazz, oh yeah, I got that. See him picking up what I'm putting down? That's what makes this unit difficult. That's why I do it first. Because really the calculator's doing the load of the work, isn't it? The work. But you got to know what you're doing to make the calculator work. Everybody with me? Okay. So you guys have 25 minutes left in class. I expect you to be a little more efficient than my regular 10 class. But I want you guys to do, your next sheet should say problems and applications. Does it? Okay. That's your homework. It's tricky on purpose. Don't jump at the first answer that pops into your head. It's the only hint I'm giving you. Just the next 4. That's your homework. But wait, I'm giving you something else. Okay? In class, I want you guys to work on, you probably don't have this sheet, worksheet 1-6, do you? Is it in your notes there? I lose track of who has what. You guys don't have this. So this I got to print off for you. I apologize. That is my fault, not yours. I'm a dunderhead. So you can start on those problems and applications if you want, right? But I want you to, I want you to take home. I want you in class to be working on the 1.6, which, yes, somebody is Mr. Myersing me. You have 1.6. I did something right. It's just stapled in the wrong order. It's stapled towards the back. Oh, thanks, you guys. So do 1.6 first, because it's easier. It's less tricky. And then move on to the problems and applications. Everybody good? Does it say 1-6 at the top? I can't read that from here. Yes? Then that's what I want you doing. Now, guys, 1-6